Today in our physics chapter, moving charges and magnetism, now to see one numerical. The numerical is like this way, just you can see here. What is the radius of the path of an electron? That is, mass is given 9.1 into 10 to the power minus 31 kg and charge 1.6 into 10 to the power minus 19 coulomb. Moving at a speed of 3 into 10 to the power 7 meter per second in a magnetic field of 6 into 10 to the power minus 4 Tesla perpendicular to it. What is its frequency? And second, calculate the energy in kilo electron volt. 1 electron volt is equal to 1.6 to 10 to the power minus 19 joule. Now we first will get the radius of the, that is the radius of the path. R is equal to mv sine theta upon b into q. Now here mass is given, that is m is equal to 9.1 into 10 to the power minus 31 kg. V is given, that is 3 into 10 to the power 7 meter per second, and B is equal to 6 into 10 to the power minus 4 Tesla. And here V and B both are perpendicular, so finally theta is equal to 90 degree. Now keeping the value here, and Q is also, we know that Q is equal to 1.6 into 10 to the power minus 90 coulomb. Now keeping this value, we can get here R is equal to M 9.1 into 10 to the power minus 31, V, that is 3 into 10 to the power 7 sine 90. Sine 90 means 1 divided by B 6 into 10 to the power minus 4 into Q 1.6 into 10 to the power minus 19. Solving this, we will get here, that is a 0.2812 meter or 28.12 centimeter. That is R. Now we will get here the frequency. So we can use the formula here, frequency, that is here V is equal to R omega is equal to R into 2 pi F. Therefore F is equal to V upon 2 pi into R. V is given, that is 3 into 10 to the power 7 upon 2 pi means 3.14. R, that is 0.2812. Solving this, we have to get here. Solving this, we have to get is equal to 1.699 into 10 to the power 7 hertz, or you can add here 16.99, that is into 10 to the power 6 hertz is equal to 17 megahertz. Now we have to get here the energy of this. So we know the formula, that is energy is equal to the kinetic energy, of electron, that is Ke is equal to 1/2 mv square. Now keeping the value here 1/2 m means here 9.1 into 10 to the power minus 31 into V 3 into 10 to the power 7 whole square. Now we have to convert into that is electron volt, so we can divide it by 1.6 into 10 to the power minus 19. Solving this, you have to get here 2.531 into 10 to the power 3 electron volt. Now again simplifying, we have to get here is equal to 2.5 kilo electron volt is equal to kinetic energy of a electron. So this is to understand this numerical. In this numerical, here the electrons are entered normal to the magnetic field and executing circular motion. Then the radius of the circular motion R is equal to mv sin theta upon bq. Here v and b both are normal to each other, therefore theta is equal to 90. Keeping this value here, therefore r is equal to m, that is 9.1 into 10 to the power minus 31. V means 3 into 10 to the power 7 sin 90 divided by q, 1.6 into 10 to the power minus 19, and b is equal to 6 into 10 to the power minus 4 Tesla. Keeping this value and simplifying it right here, r is equal to 0.2812 meter or 28.12 centimeter. Now we know that here we have to get the frequency. V is equal to r omega is equal to v is equal to r into 2 pi f. Therefore f is equal to v upon 2 pi r. Now therefore f is equal to v means 3 into 10 to the power 7 upon 2 into pi 3.14 into r 0.2812. Simplifying we have to get here, that is 1.699 into 10 to the power 7 hertz, or that is 16.99 into 10 to the power 6 hertz is equal to 17 megahertz. After that we have to get the kinetic energy of the electron. Kinetic energy of the electron is equal to 1/2 mv square is equal to 1/2 m means 9.1 into 10 to the power minus 31 into v, that is 3 into 10 to the power 7 whole square divided by 1.6 into 10 to the power minus 19. So that will give the answer in electron volt is equal to 2.531 into 10 to the power 3 electron volt is equal to 2.5 kilo electron volt. So this way to understand this numerical. Thank you very much.